We are going to learn about shapes today. So, um, we're going to get some, we're going to learn about, we're going to learn to get some familiarity with our turtle. And we're also going to learn how to use, for loops today. We're going to kind of build up to that naturally. We're going to be basically spending the next couple of weeks on for loops and turtles. So let's go ahead and share my screen for a second. Share. We're going to just share this part. Okay. So here we are, right? Go to modules, module 3, and I'll also send this link in the chat so that you'll have access to it. 55 students, really? I mean, it's Zoom. Come on, people. It's easy. All right. You go to module 3, and over here, what we'll do is we will go to, scroll down. I have these videos over here about that correspond to chapter 3 and chapter 4. This one's especially useful. And then on Tuesday, I fixed the link for today, which will, you can click on this link and it'll bring you to Runestone, or you can get there from Runestone directly, or you can just simply take what I'm dropping in the chat. Okay. All right. So again, if you go in through Runestone, we just simply click Foundations, scroll all the way down, and it is Project 4. All right. So the idea here is that we want to build up to drawing a circle. Okay. The idea here is we're going to try drawing a circle using Turtle. Now, to remind you, we're going to be using a library called Turtle, and we're going to be basically using only the most basic of commands for Turtle. We're going to start by drawing a triangle because that's a bit of a simpler shape. And so our first task is to ask the user for a side length and then draw a triangle. Now, we're assuming here that when we're drawing shapes here, for this exercise, we're assuming we are drawing regular polygons, which means that these have basically the exact same size for everything. So same angles, same side lengths. Okay, making it nice and easy, right? So what are we going to do? We are going to first remind you how to build a turtle. So to use turtles, to start using the turtle, we basically need 2 commands to start with. Import turtle. That's the first thing that says we're going to use the turtle library. And then the second thing to say is we are going to basically say, and obviously you don't want question marks there since that's all red. Turtle dot turtle. This is the only bit of black magic. We know what this does now, which says, hey, we're going to use the turtle library. So this program's going to rely on turtle commands. And this one over here says, hey, let's go ahead and create a new turtle. Turtle.turtle. The capitalization does matter, as do these parentheses. And then we store this in a variable. You can think of this variable as the turtle. I like to call my turtle Bob because it is 3 letters long and 1 variable. Sorry, 3 letters long and 1 syllable long. Right, so very easy to say, Bob. Okay. And if we save and run this, nothing really happens because we didn't tell Bob to do anything. But if I tell Bob to go forward by 50 pixels, remember, the distance is in pixels, he will do so. Okay. So really, we just need to know about 3 commands today, and technically only 2 if we're turning left and right. If we're only turning left and right, since we only need to turn in one direction, right? We can do Bob dot left 30, and then tell him to move another 50 pixels, and he'll do so. He turns 30 degrees to the left and moves forward 50 pixels. Make sense to everybody? So we learned, I mentioned a whole bunch of commands for turtles. last time, but really to just start out with, and honestly, on your exam, you only need to know three for the most part: forward, left, right, backward. Backward or backwards? Let's find out. Backward. Backward. It's backward. And then up. Sorry. Pen up and pen down. These all can actually be abbreviated. So if you are exhausted by typing out the 7 letters that are forward, you can actually just do FD, LT, RT instead, like so. And they work exactly the same. They're just shortcuts or abbreviate. Better, no, they're just abbreviations. Backward doesn't, BD doesn't exist. What is that one? Oh, BK, I bet. Yep. There we go. And then these are even more straightforward: up, down. I swear I know how to spell. Okay. Okay. So our task now is to ask the user for the side length and then draw a triangle. All right. Why are you getting errors? What did the error say? Did you, if you were copying down this, did you put think how to say comments in front of them? Did you capitalize correctly here? Did you remember to import turtle? I need to know, basically I need to know what errors you're getting. You misspelled turtle. See, that's what it means by, it says you've got the T before the L. So let's see. So your task for right now is forget about asking the user for a side length. We're going to adjust that in a bit. Just draw a triangle. Specifically, draw an equilateral triangle where basically everything is equal on all sides. Make sense? So basically, all sides are the same. Okay? So do your best to try to draw a triangle. Now, a triangle, let's just think about a second. Since we're going to be lazy, we probably will tell the turtle to make its first stroke by going this way, right? So the first question you have to ask yourself is, if this is, say, 50, and you're probably going to do 50 because I did 50, I want to draw something at 50 over here. That's no problem. We just tell them to move forward 50. The question is, how do we make our turtle turn, right? If we want to draw a triangle. Okay? Now you might be thinking to yourself, okay, this triangle, right, that I'm drawing, its angle over here, we learned that basically a triangle has 180 degrees, right? You learned that's internally what we have for these things. And so you're thinking myself, so you might think to yourself, okay, what I need to do is bob dot left 60 degrees. But think about where that's going to end you up or make you end up. So, right, this is 90 degrees over here. This is 90 degrees. And you're facing this way. So turning 60 degrees brings you only really over here, which is not the way you need. So the question is, if you're only turning 60 degrees, and really what you want to be doing is going over here, how much do you actually want to turn? Very good. 120. You want to turn 120 over here. The other shapes, like squares, are a bit easier. But yes, you want to turn 120 degrees. So with that, take a gander at it. I'll give you 5 minutes. If you're already done with that one, feel free to move to the other one. I'm going to go ahead and pause our recording. I'm going to keep the recording going because uh, otherwise we will forget. So to redo it. So okay. All right. That was just a reminder for me. So now let's go ahead and get back to drawing this. So to draw a triangle, what we're going to do is, for right now, I'm going to keep this as just like 50. I know for a fact that if I'm drawing a triangle, I'm just going to keep it nice and verbose right now because I can, that I'm going to need to do this 3 times, right? I'm going to draw something 3 times essentially. And we can kind of see that I've got 3 line segments and I just kind of got to pick them up and move them into the right places. Right. Let's go ahead and do Bob dot right, or I'll do left 20 and do left 20 here. Why 20? No particular reason. What I'm doing is just basically saying here, you see I have a segment, right? Probably better if I show you 90, right? That we have a segment over here. I have 3 segments and I really would like to put them together in a triangle. Just kind of move them around. Okay. Well, we blow them up. We can have a bit of a bigger one. It doesn't really matter as long as they are the same. Right? Easier to see. There we go. All right. So the question is, how do I do this? Well, what I want to do is, through the power of annotation, I want to draw, go and get a thicker pen. All right. We want to go over here, and then we want to turn so that we get over here. we're turning from this direction all the way this way, right? So that such that the inner angle would be 60 degrees, which means that, and since the turning around in, from going one direction to the other direction is 180 degrees, we can subtract 180 minus 60, and that gets us to 120. Okay, gets us that complement. So we we turn, and then we get this. And then we would want to go, and then now while we're here, again, we're facing this way. We want to turn that exact same amount, 120, and go back. So in the end, basically, we're repeating the same thing 3 times. Bob forward 100, turn left. Let's go ahead and 120. Copy paste 3 times. Clear the drawing, and there we go. We've got our turtle going 1, 2, 3. Just like that. And I always like, yes, technically this bit isn't necessary over here at the end when we're drawing a shape, but I always like it because that means that my turtle has now traveled 120 plus 120 plus 120, which is 360 degrees, which is a full circle. He's gone around in a circle. That means he's facing the exact same direction as when he started. And as it just so happens with the way we're drawing these shapes, he ends up in the exact same position. So he's exactly back at 0, 0, right? And that's important. By the way, I say 0, 0 because this thing that he's drawing on is the Euclidean 2D plane. It is your standard plane with him starting at 0, 0. And we can actually see that. And I'm just going to take an aside over here. We can actually see that. And I'm going to do this to comment out multiple lines at once. Okay. We can see that by telling him to go bob dot go to space 50 comma 50. That's an XY coordinate. Let's go ahead and remember let's go actually to 50 comma 100 so we can see it a bit better. And we see that Bob goes forward X 50 and up 100. This is an XY coordinate plane. How far does it go? Well, at least for here in our in Runestone, it's a 200 by 200. Sorry, it's a 400 by 400 with each quadrant being 200 by 200. So just because the graph isn't drawn doesn't mean it's there. You don't really need to use GoTo too much, but I figured I'd let you know that we're just working on something that you've been doing since basically algebra. Okay. So now that we've got this, right, how do we get user input? Well, what's important to note is that we don't have to put exact numbers, literal numbers in here. We could instead put a variable, like side is equal to 100 instead, same exact value, and I just replace all of them. Make sense? Same thing. Same exact thing. Okay. I can also, now that I've got this, like this, ask the user what they want to put in inside as their side instead. And we do that very straightforward by asking for their input. And I always like to do the input last because it slows down how quickly I can test my code. So input, enter side length for triangle. All right. And now side is equal to, and now we got to basically turn it into a number, because if I try to do this, what happens? Well, actually, do we? Let's find out. Will it automatically convert it? It does automatically convert it for us, but good practice is that we should convert it into an integer. Specifically, it already converted it over here, right? If you put in apple as the side length, it's gonna get really confused and not do anything. So instead, side is equal to int side to make sure that this will convert whatever the string was into a number, and thus we know that our number is going to work. And so so there we go. I'll definitely share this with you just in case you need it. And you can always just get the code that I shared with you by hitting the reload button on your page. And then it will appear in your timeline at this time. Now, the reason I did that is because it is now your turn to try to draw a square from beginning to end, do all this by yourself. Okay? If you haven't done that already. So go ahead and take the chance to do that. Excellent. I'm glad you did it. We're going to be building up to, once we get over here, we're going to be building up to the octagon, and I'll show you about that, and we'll be introducing for loops over there after we do this one. So we are going to, I'm going to go ahead and keep this bit open. Ethan, excellent question. Ethan asked, can we just, instead of doing these two lines, can I instead do just this line, which is int, which is to take the same exact input that we have, right? And do it like this. And the answer is yes. But the answer is also that this looks, nesting our parentheses this early on for a lot of intro students does look a bit more intimidating. So I do try to make our lines, especially at the beginning, just do the minimal thing possible, one thing at a time. Take an input, then convert, rather than taking an input and convert it at the same time. So that's just a pedagogical kind of preference. You're more than welcome to do that yourself. I often don't care how you do it, so long as it works. Let me go back and resume and put 3 minutes back on that clock. It's melted a bit. That's how square looks melted a bit. Got to get it out in the ice here. You know, plenty of snow around. All right. So let's go ahead and take a look at this. So like, I'm just going to do this from scratch because I believe that that's a better, more efficient way to do this, at least for teaching. So we're going to import our turtle. We're going to do Bob is equal to turtle.turtle. Again, you don't have to call it Bob. You could call it Alice. You could call it, I would not call it turtle though. That could make things confusing later on. Okay, Bob is equal to turtle. And we need to draw a shape, right? We need to draw a square. Drawing a square is, why is it giving me 10? Okay, come on. We need to draw a square. And drawing a square is actually fairly not too painful, right? We know how to draw a square. We draw a line, a line, a line, and 4 lines. We draw 4 lines and they have 90-degree turns, right angles. So Bob dot forward. Let's go with 100. Bob dot left 90 degrees. And what we're going to do is we are just going to copy paste this 4 times. 1, 2, 3, 4, right? Save and run 4 times. All right, now we need to let it take input. So let's go ahead and say side is equal to side input side, enter a side length. Typing and talking is actually really hard to do. And then we'll convert it into an integer so that we can use it. Side. And we will run it, and I'm going to make it really big. But it's not going to change how it does because anyone tell me why? What did I do wrong? Why didn't it make a really big square? This is possible. This is an error I make all the time, and you will make all the time. I did not use the user input. That's right. I basically got the variable and then proceeded to completely ignore using it. So I didn't change out my 100s for that. Make sense? You will do this a lot, by the way. A lot, where you'll create a variable, run it, and like, oh, right, got to use it. So you'll as you make mistakes, you'll have a running kind of tally of all the mistakes you've made and common errors you make. And so now when I do this 200, you see it goes basically to the edge. Yes, Alex, what's up?
I keep getting an error for some reason.
What error?
I got an error on line 1. It says that there's no module named turtle.
Did you spell turtle correctly?
Let me check. Yes, it looks like
Interesting.
that it's spelled correctly on my end.
Why don't I go ahead. You want to drop your code in chat
Oh,
or
actually, wait. I didn't know. I forgot the T.
there we go.
Yep.
All right. Now, time for our kind of side lecture here. Ask a user for a side length and then draw an octagon, which is an 8-sided thing. So we can just kind of copy paste at this point, right? Copy, paste. And we know we need this to be 8-sided. All right, and an octagon, 1, 2, 3, 4. I'm being very lazy on how I draw this, which is that we just simply do this. And I know it's a bit hard to see because I'm a terrible artist, right? But these angles are 45-degree angles. Makes sense. Twice as many sides, right? It has twice as many sides here. So, meaning half as many turns to make. So, let's go ahead, take this, and copy and paste it. 1, 2, 3. Let's see. Wait, oh, wait, did I do that 7 or 8 times or 9 times? Wait a second. So yeah, copying and pasting is easy, right? We can do that a lot, but it gets to be a bit of an issue sometimes because once we get above a certain number, we fail to see numbers. What do I mean by that? This is 1, right? This over here is 2. And you can probably identify this as 3. Now, some of you might identify this as 4, but others of you might identify it as 2 2s. Similarly with 5, it just depends on how you chunk it up. 6, and because of dice, we probably recognize these numbers as these series of dots as 6. But 7, 8, 9, 10, at what point do these dots start becoming, this isn't 12 dots necessarily, right? Mentally, you probably said that's 3 4s or 4 3s, and thus is 12. At some point, you stop being able to count the number kind of just by eye. And for this, 1, 2, 3, 4, 5, 6, 7, 8, 9, I did do it 9 times, which makes it a bit tricky when I want to do an octagon because I ended up going a bit further around than I want. So copying pasting isn't that great in terms of being able to do these problems. We want a way to be able to repeat stuff again and again in an exact manner and do it efficiently. Now, this is where for loops come in. So, yeah. So I'm going to boot up idle for just a second. And actually, don't need to boot up idle. I can just do it all over here. We're going to go ahead and delete all this nonsense and just use this over here to kind of show you. No need for idle at the moment, right? A for loop runs very straightforwardly. The format is always 4 parts for for loop. For loops have 4 parts in Python, and they look like this. First is the word for to say that we've got a for loop. Then we've got X. Then we've got the word in. And then we've got a thing, followed by a colon. So I guess it has 5 parts. But this is the way we read this. For X in thing. Okay? Now, here's the fun thing about this. Part 1, our for, and our part 2, our in, are always going to be exactly the same. Okay? These 2 parts are always going to be exactly the same. For blank in blank. Okay? For X and Y. For word in string. For thing in list. Okay? For number in range. Now, for today's lesson, we are just not going to care about what we put right here. So I just put in an underscore. That is shift dash. On an American keyboard, that's above, that's right by the backspace next to the plus sign, right? So I'm just going to use that blank, and that blank means we don't really care about what we put there. And as you can see in chat, some people might put an I there, but people might ask me, what are we using the I for? And it feels weird to say nothing. But Python allows you to say, we don't care about what we're putting there. Okay, so we don't care. So we get to say for blank in, and then put something here. Now the word we're going to put in today, and we're going to be using on Thursday, is the word range. Range allows us to do a range of numbers. Repeat something a range of times. So if I do this for blank in range 3, let's go ahead and see this. So this is kind of the hello world of for loops over here. Run. Hello, hello, hello world. So the main thing to note over here is that we've got for blank in range colon. Now the colon here is important. The colon tells Python specifically, we've got something coming called an indentation. Now, if you're coming from another programming language, you might be familiar with doing doing loops or if statements like this, using your curly braces. And then you indent it because you want it to be visually easy to read. Python's like, well, if you're going to be indenting anyway, then we should just use the indentation. So what we do is that we use an indentation here, this over here, and this applies to everybody. We use this indentation right here to say, hey, what is inside the for loop? Because only things that are inside the for loop we want to repeat. Like this. Now the world is inside the for loop rather than out of it. And because it's inside the for loop, we get hello world, hello world, hello world. So whatever's in here will get repeated 3 times. Hello, hello, hello. Taco, taco, taco. Right? Cat is outside the for loop. So it's going to be printed once because it's outside the for loop. It's not going to be repeated. Now this number can be changed 8 times, 100 times. Although I do caution printing out, doing an excessive number of prints. Why is that? Printing can be expensive, especially in idle, and it takes time. So it can take a while for something to print, depending on what you're using. 10. Right? So we can use this statement to repeat something a certain number of times. Now, this range function has a whole number of nifty controls we can do on it, which are meaningless now because we are not using this variable. Right? So don't worry about that. Range can take in 1, 2, or 3 things as arguments. And right now we're going to work as one. And you can just kind of think of this as the most basic form of a for loop, which is repeat this X number of times where X is the number in range. Right? So over here, let's take a look at our square for a second. We're going to go back to the square. What we could do is rather than copy and paste this line 4 times, what we could do, since we know this is going to be repeated 4 times, we can write for blank in range 4, because we know that's going to be done 4 times. Tab to put it inside the for loop, tab to put that inside the for loop, and then run it, and I'll say 50, and it does it just fine. Make sense? So a for loop we use to basically say this is going to do this many times. What is it going to do? Whatever's indented inside of it. Okay. Now not relevant for today's program, but we can have multiple for loops. So let's go ahead and just go back to 3. You can do 3, and I can have another 3. We could do taco, taco, taco. We could do cat, cat, cat. And this is not something we have to worry about today or even next week. But this is where you need to get to by week 5, essentially, which is that it will print taco, then cat, 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 then taco, then cat, 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 then taco, then cat, cat, cat. So this is where we want to be at the end. You do not need to be there today. You don't even need to be in the same neighborhood today. But that's where we're trying to get to. Make sense? You can basically, again, it's a programming language. Languages mean that we can kind of play around with it in certain ways, and we can put things inside other things. We can put loops inside loops. Nothing's stopping us, but we don't need to do that today. Today, all we need to care about is drawing this octagon. So first things first, input. Input, really? Input is equal to, not input, geez. Sides, ew, geez. No. That's what's going on. Again, trying to talk and type at the same time. I was trying to do import and input at the same time. Import turtle. Bob is equal to turtle.turtle. And then what we're going to do is we are going to say, let's see. We'll do this first. Doesn't really matter. Sides is equal to input. And then what are we going to take? Enter octagon side size. Okay. And now what I want you to do is try your best to draw the octagon using a for loop yourself. Okay, I'll go ahead and give you 3 minutes to do that, and then we'll move on to our final task. Okay. Yeah, the loops do make it easier. That's the point. Gonna mute myself for a second. What are you confused about, Neil? What do you need me to explain? So the idea here is our for is okay. I think I'm being trolled, possibly. All right. So what we need to do here is we need to use the fact that we can repeat things using a loop here. And rather than doing something 4 times, we're going to do it 8 times. I was talking to my kid. I was asking him if he wanted to explain. Uh, Professor Andrew. It's good night. Do I look mad? Do I look mad? This is hilarious. I put 8 in. I put in 8, but when I run the code, it doesn't finish the octagon. Let me go and see. Ethan, you want to drop your code in chat?
Andrew, the answers. I need them. I've been asking, I've been waiting, sitting here waiting for the answers. And you have yet to give them to me.
Very good.
I will not wait any longer. Do not mute me. Let me speak. This is America. I have free speech, First Amendment. Okay. Andrew, I appreciate you as a guy. You're an amazing guy, but I need the answers. I've been asking and asking and asking. I can't. There's nothing much more I can do. What do you want from me, Andrew? What do you want? What are you waiting for me? I need the answers.
All right, Neil.
Okay, I'm going to go back on mute, Andrew. I don't mean to interrupt class, but can you just go over?
The joke has gone on long enough. I do need to make sure that I do get enough time. I do appreciate the humor.
Okay,
though.
sorry, Professor. Go ahead. Sorry.
All right. Great job, by the way. Okay, so let's see. Taryn. Not Taryn. Let's see. Who sent me the code? Who had issue? Ethan. Ethan, your issue was that you wrote oct8 as opposed to range. So line 7 should be 4x in range, which is fascinating because oct, that is a very interesting command for what it does. For Anastasia, you gave me 7 as opposed to 8 in line 7. So there you go. All right, so let me go ahead and kind of show the answer.
Yeah, because I tried to do it 7 times, but it still drew like a full octagon.
Yep.
But then like when I tried to do 8, it would still just draw an extra line over the line that was already drawn. That's why.
Interesting.
Uh-huh.
Well, let me go ahead and kind of just go over the answer here, and then,
Mhm.
and then we'll
Okay,
see.
sure.
So let's go ahead, and we've got let's go ahead and do 4. So let's go 4 blank in range 8 because we know we want to do this 8 times. Actually, I'm also going to go ahead and I'm going to be for the next part. I'm going to go ahead and just basically rename this to be a bit better. Because sides could imply that's the number of sides, and we're going to need that for later. Blank in range 8. And what we'll do is we will basically do bob.forward. And then the side length. Bob.left. Left 45. And what we'll do is I'm going to put in 80 as our side length just because, and that fit just nice. So there. All right. So hopefully this going from one to the other wasn't too much of a big jump from any of these parts. Okay. Now, right. Basically, maybe it's the kind of a leap you need to make when you're stepping across a particularly nasty puddle, right? Not too much of a big. Now, over here, on the other hand, for this part, ask the user for a radius, then draw a circle within that radius. That does require actually a monumental leap, in my opinion. It's a bit of a stretch. I feel like they really do need to put in some more in this book, but don't worry, I will explain. So the idea here is to draw a circle. What we need to do is we really, really, really can't draw a circle. I mean, physically, we cannot. I mean, just go and look at again, I'm going to point out your screen is made up of pixels. It's made up of picture elements, made up of tiny little rectangles. There's no way to draw a mathematically perfect and pure circle on your computer. But as they point out, right, well, as we go, let's go ahead and just do this, put this in. We go from triangle to square to octagon. We are getting progressively more towards a circle-ish shape. More and more and more. We are getting more and more circly, right? And eventually we'll get to a point where our circles will not, where our shapes will be indistinguishable from circles. Give me 1 second. For instance, take a look at this particular shape, right? I learned about this during the pandemic when I'm, I've got a 4-year-old with me. He's now 9, but at the time he was 4, and he asks, and we're learning our shapes. And of course he start learning his numbers. And he asked me, what's an 8-sided shape? What's a 9-sided shape? What's a million-sided shape? And of course I have to look it up. And of course this mathematicians have given it a name, a megagon. That's a million-sided shape. But if you showed somebody a picture of this, right, and asked, hey, what shape is this? They'll probably say circle. There's probably no way in hell they're saying a megagon, right? It's like a troll question, right? But it's indistinguishable from it, but it's a million-sided shape. Your eyes can't tell. And at a certain point, and that point is actually rather small, you aren't going to be able to tell the difference between drawing this. So before we go on to drawing a circle, let's talk about how can we abstract this, make this abstract so that we draw something of a shape of any particular size. or sorry, a shape of any particular amount of sides, let's say. Okay? So for instance, what do I mean? I'm just going to use this blank one we have over here. Import turtle. Bob is equal to turtle.turtle. For blank in range. And what we're going to do is that we're going to ask the user, sorry, I'm not going to even bother asking the user. This is the number, I'm going to let sides be not the length of the sides, but basically when we draw something, we need to know three things. We need to know the number of sides we want. Let's go ahead and go back to our octagon and figure out 8. Okay. Then we want to know how big it's going to be, the side length of each side, right? How big is that going to be? And you know what? I'm just going to plug in a number for right now. I'm going to do 800. Okay. I'm going to do 800. I'm going to do 100 for right now, even though that's probably a bit too big. Whatever. And then what I'm going to do is that we need to figure out how much we need to turn. With an octagon, we needed to turn 45. With a square, we needed to turn 90. And with a triangle, we needed to turn 120. Now the answer is actually all the way back over here in the triangle. When I mentioned when I copy pasted this 3 times, I mentioned, oh, I could have left this off, but I like my turtle to be pointing the same way as when it started. And that's not a coincidence, because I said when he's done turning, he's gone a full 360 degrees. When we are drawing a shape like this, a regular shape, the turtle is going to turn a grand total of 360 degrees. And that makes sense to everybody? Look at this over here. 45 times 8. That's the same as doing, make the math a bit easier. 45 times 8 is the same as 90 times 4, right? And we've already seen that. 490 turns is 360. So this is 360. Okay? So the angle that this guy needs to turn, that Bob needs to turn, it's got to all add up to 360. And we got to split it into multiple parts. How do we split it into multiple parts? We'll divide it up among each of the turns, right? This gets an equal amount. Sorry. This will get an equal amount to turn. This will get an equal amount to turn. This will get an equal amount. And this will get an equal amount. There were 8 turns, so we divided by 8. If there were 4 turns, we'd divide by 4. And if there's n sides, we're going to divide it by n. So, sides. Does that make sense? So let's go ahead and just kind of not even bother with basically doing the and making a move. Bob dot left. Oh, okay. Question about this. That's integer division. Right? That's just going to make sure, that's just going to cut off all the decimals. This will basically say, hey, if I can't evenly divide it, I'll have a point in there. This will basically so basically, if I try to divide by 13, it might be a bit uneven. Versus if I try to divide by 13, it will give me some amount of, it'll give me a whole number, an integer. So let me just go ahead and Bob.left angle. And what we can see here is every time I hit run, he spins around. Everybody seeing that? He's spinning around at the bottom. Right? And he does 360 degrees because he's spinning this amount, which is 360 divided by sides, and he's doing it 1, 2, 3, 4, 5, 6, 7, 8 times. Sides number of times. So if it was a 100-sided thing, it doesn't divide as evenly. Let's actually see if I do this. There we go. The double slash does makes it an integer. Let's go ahead and make sure. Okay, screen isn't sharing. So let's go ahead and stop share. And we will reshare. since that will bring everybody back into focus. Okay, so let's go ahead. 360 divided by the number of sides. So if instead now I tell him to move Bob dot, let's go ahead and do a four-sided shape. Bob dot forward side length. And so now we've got basically the same thing to do everything here. So, oops. There we go. 4. I can switch it over to 5 here now. Switch it over to 6. Switch it over to 7. Switch it over to 8. Switch it over to 20. Let's make this a bit smaller now because because the sides are getting so big that we're going out of the screen. Side length 20. I will. Notice this looks pretty darn that we're down to 20. We're only up to 20 sides, and we're already looking at something that looks pretty darn circular, right? 30 gets really circular, especially if we shrink how big the side length is. It doesn't take much to get ourselves a circle, right? Let's go ahead and share this code, because this is where it gets a bit tricky. Okay. So now what we want to do is ask the user for a radius and then draw a circle with that radius. So let's go back to a bit of geometry. Okay. Okay. I'm not going to subject you to my handwriting. Right? The perimeter is equal to the of any shape, right? Doesn't matter if it's regular or not, is equal to the side length to the number of sides we have, right? So we could ostensibly calculate the perimeter of any object, any shape we drew, by just taking these two things and multiplying them, right? Make sense to everybody? Everybody follow, right? We drew 30 sides, each of them are 15 long, so we would just add 15 30 times together, or multiply 15 by 30, right? That gives us the perimeter of a shape. Now circles are special boys, right? They are special because they don't have sides, right? They don't have a perimeter. They get their own special word, the circumference. I believe that's how we spell it. The results are for circumference. Okay, circumference. Circumference. Right. I misspell things plenty, but I always like to be right. So the circumference, right? We learn about special kind of formulas for circumference and for special terms for a circle, right? So the first thing we learn is that a circle might have a radius and a diameter, but really they're the same. They're kind of intrinsically tied because the diameter is just twice the radius, right? And what is the diameter? Since a circle is just kind of this magical shape. Go ahead, and I believe I have the ability to draw shape. Close enough, right? Circle is a magical shape where basically anything from the center is of equal distance, right, to the edge, right? This value is called the radius, the distance from the center of a circle to its edge. We've learned all that. So the radius is equal to our input. It's what we're going to be given, right? Now, circles, as I mentioned, let's go ahead and draw a highlighter. Use red, right? No, need blue because that's a complement, right? The value that we're going to be going around this circle is not the perimeter, that's the circumference. That's basically the equivalent thing for a circle. Okay. So how do we calculate that? Well, we learned a formula all the way back in our math classes for figuring out what the circumference is. It is 2 times pi times the radius, 2 pi r. Now, okay, and we could import math and get pi, but we can define pi fairly easily, right? We all know it, 3.14, and then if you know more digits, 159. Laser, what's the digits of pi after 9? 3.14159, 26535, 85792. He knows a lot of pi. I don't know why, but he learned it at some point. The mate, not 8589. But point being is that 3.14159 is probably more than enough than we need to know for here. Okay. He's got a snow day today. He's over on his computer all the way on the other side of the room. But he's being shy. He did not want to participate in today's class. So anyway, pi is equal to 3.14159. We've got our radius, 2 times pi times the radius. We've got our circumference. Okay. Now, why do I care about this? Well, because this turtle is going to need to do some amount of going around in a circle, right? It's got to go around some amount. And telling the user to enter in a side length doesn't work. We want him to enter a radius. So the question is, how big should we make the circle? And the answer is that we need to make this value, side length times number of sides, kind of equal to this amount. It's just a way of saying, hey, we've got the circumference. Okay. It is 2 times pi times the radius. So we can calculate that fairly easily. Let's go ahead and grab this. So radius is equal to user input. I'm just going to say we want a radius of 100 for right now for our shapes. Okay. We'll leave the input for another day. Pi is equal to 3.14159. And then finally, we are going to go ahead and say circumference is equal to 2 times pi times the radius. So why do we care about this? Well, rather than figuring out, well, what we can do is that we can calculate side length to be equal to the total amount of circumference divided by the number of sides we have. Just how like we're equally split, how the angle gets equally split up. We're going to figure out, okay, the amount I need to draw is equal to the circumference, the total circumference that I want to draw, this total perimeter split up, right? See how basically we can get the side length by taking the original perimeter and dividing by the number of sides. And that's essentially what we're doing here. Since we don't have a circumference, really, we take this equation, we're going to divide it by the number of sides to get our side length. And now when we put this in, okay, whoops. Yep, we get it just did on its own because I told it to. So 100. Let's go with a 50 sided radius, size 50 radius. Let's go ahead and go back to 100 size radius. And what we're going to do now is we're going to up the number of sides to like, we're going to go down to maybe, actually, let's go down to 5. Now we're going to go up to 50. And that's what a 50-agon looks like. I'm going to hit share on the code. Because it is getting, I normally would give you chances to work on this, but I was cognizant of the time, it being 3:10, right? And because I want to talk, and so this is how we this is how we draw a circle. We fake it, right? And depending on how big we need to make it, our circle, we can kind of dynamically figure out the sides of this. Okay. This now, before you go on, so 2 things before class is dismissed we're going to do. Okay, so don't sign off yet. First off, if you want to just extra practice, you can try this over here. Second, be sure to fill out these dials over here. Okay, so that you've marked everything complete, so you get full credit for this. Now, before you leave, I want to go over, right? I know that we've got so first off, for lab 2, what's that? I sent out let's go ahead and get rid of this over here. Lecture recordings. I sent out a lecture yesterday. Lab 2 overview over here, so that you can basically, to make up for the fact that you may not have had the lab yesterday, or your TAs may not have held an extra session yesterday to help with that. So lab 2 is there, an overview of it to help you with it. Okay, second, lab recordings, right? If we go back to to lecture recordings again, right? Remember, this is a playlist. So if you've missed your classes, just hit this button right over here, and you see it's a playlist gone in reverse, right? And today's lecture will end up there as well. Okay, let's go now to now, even though this hasn't been turned in yet, I do want to take a moment to kind of show you lab 3, which I find to be a really fun lab because it is turtles, hence the name Turtle Loops. It depends on the programming language. If you delete main in this part 2 of lab 2, it's not really going to matter. Okay. Do not name your homework turtle.py. It will result in a 0. It leads to pain. Just don't do it. Okay. Because I have an entire video about why naming something, the name of something you're trying to import, can lead to problems. So first off, problem 1, Turtle Olympics, write a program or a function, if you know how, that uses turtle or turtles, and I recommend using 5 turtles to draw the Olympic ring logo. And for those of you who don't, okay, Olympic ring logo. I know I'm not there on there. So they're generally very protective of their copyright. But honestly, I don't care. It's silly. Everybody knows what the Olympic symbol is. Okay. Now notice here that, right, you want to get the colors in order for regular credit. So basically have them over. Now, as long as they're on top of each other, you're getting regular credit. The extra credit is getting them to interweave above and below correctly. And I recommend using 5 turtles for that because there's no easy way to do it. It's very tedious, but that's why that's extra credit, to get them to interweave. So like the red is above over here and below over here. Make sense? Okay. And if you're stuck on that one, I'll be happy to discuss that one with you. Okay. But just simply getting 5 circles to overlap of different colors, that's regular credit. Draw the analog face of a clock using a turtle. It should resemble this. How do you change the thickness of the turtle path? There's a chapter in the textbook that talks about that, but there's a width function. You can find everything you need to know about turtles in the Python turtle docs right over here. And we see there's a width function for changing a turtle's width, or also known as pen size. But very good question. Okay. Next, one thing I didn't need to press on it yet, but we've got this over here for drawing the face of a squawk. How'd you draw something like this? It's not 12 separate turtle. It's just one using a function called stamp. Stamp is a fun function where essentially he makes a belly flop on the page of ink. Number 3 is initials. Write a program or function that draws your initials. Okay, using turtles, obviously. This is definitely biased against people who have a J, right? If you have a J, right, I am so sorry because of that hook, right? But I mean, if it needs to be a blocky kind, if you've got a B and you end up doing a blocky kind of thing like this, whatever. As long as I can legibly understand it's your initials, we're fine. Okay? Draw shape. We kind of just did that. And then drawing the Triforce, which is this triangular pattern over here. So that is your assignment for the upcoming week, Lab 3.